We've got four reactions set up for us to balance. This first one is going to be pure sodium metal being put into water, which, if you've ever seen, is an explosive reaction, and it produces sodium hydroxide and some hydrogen gas. So the first step here is to write out the elements that we have reacting. We've got an Na, an H, and an O, okay? And so we want to take an inventory of what we have on each side of this. On the left side, I have one sodium, I have two hydrogens, and I have one oxygen. On my right side, I have one sodium, I have one oxygen, but I have one, two, three hydrogens. And so I need to balance my hydrogens. That's the only thing that's out of balance here. And in order to do that, I can only add or subtract one of these molecules. So I'm going to do that to this H2O. I'm going to add another H2O here. That's going to bring my total hydrogen count to 4. And my total oxygen count to 2. Okay? So I need to make sure that I'm keeping track of which elements are going up, because I can only add a compound. I can't just add a single hydrogen atom. I have to add the entire water molecule. So then what's going to happen on the right side? Well, now I've got hydrogens out of balance and oxygens out of balance. Well, if I put a 2 here, well, then that's going to bring this up to 2. It's going to bring this hydrogen count up to 1, 2, 3, 4. It's going to bring my oxygen count up to 2. Okay, great. Okay. So now I just need to balance my sodium. So I just put a 2 here, and I've got 2 sodiums. And now my reaction is balanced. And so the correct answer would be 2 sodiums, 2 waters, creates 2 sodium hydroxides and 1 molecule of hydrogen gas. Let's look at our next one. This is going to be C2H2. It's going to be ethene. We're going to react that. This is going to be another combustion reaction with oxygen, creating CO2 and H2O. So once again, let's start by listing out the molecules involved, C, H, and O, and count up how many I have on each side. I've got 2 carbons on my left side, I've got 4 hydrogens and 2 oxygens. On my right side, I've got 1 carbon, 2 hydrogens, and 3 oxygens. Notice my oxygens are in 2 places, so I'm going to need to keep track of both of those places. So first, let's start by balancing the carbon. And so I'm going to put a 2 here in order to get this carbon up to 2 to balance that. That also means I add another 2 oxygens, because I've got 2 molecules of carbon dioxide, and in each molecule of carbon dioxide, there's 2 oxygens. So that means I'm going to have 2 times 2 is 4, plus this one over here, going to give me 5. Okay, now how about the hydrogens? Well, if I add 2 here, then that brings this count, 2 times 2 is 4, brings this count up to 4, and now I've got 2 times 2 is 4 oxygens, plus 2 times 1 is going to be 6. Okay, so my carbons are balanced, my hydrogens are balanced, and I just need to balance my oxygens. And so I come over to my left side and I see I can go up by 2's. So 2 times 3 is going to get me 6 oxygens. And so now I've got 2 carbons, 4 hydrogens, 6 oxygens, and I'm balanced. So this is my balanced chemical reaction. Just going to take this one out of here because I like these things to be neat. Okay. So next we have ammonium carbonate breaking down into ammonia, CO2, and H2O. So I'm going to track all of my different elements. I've got 4 here. So I've got nitrogen, I've got hydrogen, I've got carbon, and I've got oxygen. It's going to be a little more difficult. We now have 4 atoms to keep track of. On my left side, I've got NH4. This is going to be ammonium, and there's going to be 2 ammoniums in this. That means I've got 2 nitrogens. Hydrogens, I've got 2 times 4 is 8. Carbons, I've got 1, oxygens, 3. On my right side, I've got 1 nitrogen, and I've got 3 hydrogens here and 2 of them here. That means I'm going to have 5. And then carbon, I've got 1, and oxygen, I've got 1, 2, 3. Okay. So this might look like a really challenging reaction. So what can I change here? Well, I'm just going to start with the top atom, this nitrogen. We're just going to get that balanced first and see where that brings me. I'm going to put a 2 here in order to balance that. So when I put a 2 there, that nitrogen becomes 2, and now that's balanced. And now I need to add up my hydrogens. So I've still got 2 from this water molecule right here. I've got these 2 hydrogens. I've got 3 from each ammonia, so 3 times 2 is 6. plus 2 gets me 8. And oh, look at that, balanced. So it looked hard at first, but really balanced quite nicely. So let's do one more, nice and challenging. And in this one, notice I've got this PO4 here, this phosphate group. And notice that on the other side of the reaction, it stays the same. It does not change. The PO4 does not change. So I could track this as phosphorus and oxygen, but it's going to be a lot easier to track it as a phosphate group. Okay? So I'm going to do that. So I've got sodium Na. I've got phosphate. Now phosphate is PO4. This is a huge common mistake. When people track this, they'll sometimes write it as PO and then say there's 4 of them. That is not what this is. Phosphate is PO4. It is 1 phosphorus, 4 oxygens. It looks like this. So when we're tracking phosphate, we are tracking this molecule. So we need to make sure we have PO4. There are 4 oxygens, 1 phosphorus, not 4 POs. You need to be very intentional about those numbers. They are very specific. Okay, and then we've got calcium, we've got chlorine. So how many of each of these do I have? I have 3 sodiums. I have 1 phosphate. I have 1 calcium, and I have 2 chlorines. Over on the right side, calcium, I've got 3 of those. PO4, I've got 2 of those. Notice it's in parentheses because I've got 2 of this entire thing. This 2 right here applies to the whole phosphate group. Okay? That's why these parentheses are here. So I've got 1 sodium and 1 chlorine. And so where can we start here? Well, my strategy is always just to start at the top. Starting with sodium, I need 3 sodiums. So I'm going to put a 3, I'm going to use a different color for this. I'm going to put a 3 right here. So now my sodium goes up to 3. My my chlorine also goes up to 3. Okay? So that's like that. Great. Now, phosphate. 1 versus 2. So I'm going to need 2 phosphates on my left side. So I'm going to put a 2 up here, and that brings my phosphate up to 2, but also changes my sodium. So I'm going to have 6 sodiums. Well, now what? Well, now whenever I get into this situation, I'm going to go back up to my first element. I'm going to rebalance that. And if that doesn't seem to be working for me, I'm just going to look at if I've got any common fractions, like common denominators or common multiples that I can use. So I've got sodium here, and I'm going to make this a 6 in order to get this balanced. So now sodium's at a 6, chlorine is at a 6. All right, and so sodium is balanced, phosphate is balanced. Now let's come to calcium. Calcium has 3 on the right side, 1 on the left side, so I need to bring 3 on my left side. So it's going to bring me 3 calciums, and then 3 times 2 chlorines. 3 times 2 is 6. And look at that, everything is balanced. So it worked out nicely. So we should be getting familiar with how we balance these equations, what numbers we can change, and how we're able to bring more molecules or a different ratio of molecules, but that we're keeping these chemical formulas, that these chemical formulas are remaining unchanged when we're balancing the reaction. Because this is a specific chemical, this is a specific substance. And changing the substance can drastically change its properties. Consider H2O. This is water. We drink it, we need it to survive. Consider H2O2. This is hydrogen peroxide. If you get some hydrogen peroxide at the store, you probably get a 3% solution, which is 3% hydrogen peroxide, and the rest is water. And when you put that on an open wound, it'll help disinfect it. But pure hydrogen peroxide, if you get even a 30% solution, get that on your hands, it can start to eat away at your skin. This is deadly. It's toxic. It's poisonous. You could not ingest this. This, water, you need it to live. So even just one difference is going to drastically change the properties of this chemical. So when we balance these chemical reactions, we need to make absolutely certain that these chemical equations, these chemical formulas, are staying exactly the same. We cannot change them. We can only bring more or less of that entire chemical. Cannot stress that enough.